Today we are continuing on with our solving of inequalities. So you're going to see something in this lesson that you didn't see the other day. I did briefly talk about it though. So, number one thing, remember solving an inequality is much like solving an equation. Your goal is to get the variable by itself. Okay, in this first problem, I'm just going to work it like I didn't know any different. I didn't know there was a special rule. So this is a -1 in front. I undo multiplication with division. So I would divide both sides by -1. I'm going to keep the sign the same. A negative divided by a negative is a positive. Now this down here says, now choose a number that satisfies the inequality. This is saying that any number greater than 5 would be an answer to the problem. So let's look at that original problem again. Let's pick a number that's greater than 5. What do you want to pick? Let's say 7. So if I put 7 in the x, because that's a number greater than 5, let's see if this statement is true. Is -7 greater than -5? No. Does it make sense? No, it doesn't. What would we have to do for it to make sense? Well, if this sign was flipped around the other way, -7 is less than -5, that would make sense. That would be a true statement. So this is the rule that I briefly mentioned the other day. Whenever you divide by a negative number or you multiply by a negative number, whatever this inequality sign is, you flip it around. So now, shoop, it goes the other direction, and you get your answer. So let's go ahead and put that in writing. When you multiply or divide by a negative number, you flip the inequality symbol. So it's not about getting a negative answer or a positive answer. It's about whether you divide by a negative or if you multiply by a negative somewhere in the problem. So if I just had the problem, let's say 4 plus x less than -7. So I would subtract 4 from both sides. The x would drop, the symbol would drop, and I'd get a -11. So I get a negative answer, but I don't flip the symbol. And that's because I never multiplied it by a negative number or divided by a negative number. All I did was I subtracted. So the only time we flip the sign is if we multiply by a negative or divide by a negative. Okay, I am not doing this because this is not something that I stress. So let's practice solving these, and then we'll go ahead and we will graph it on a number line. So I'm going to circle everything smushed with my x. Whatever's outside the circle, I add or subtract. So I'm going to subtract my 4. The -7x drops. The symbol drops. 18 minus 4 makes 14. I undo multiplication with division. So I would divide both sides by -7. And because I'm dividing by a negative number, I need to flip around my inequality symbol. So now it's going to look like that. And 14 divided by -7 makes -2. So since we divided by a negative number, we have to flip around the inequality symbol. So if you multiply by a negative or you divide by a negative. Okay, let's go ahead and graph this. I'm going to put -2 on my number line. Would it be an open circle or a solid circle? Solid because it has the equals. Since the pointed end is facing the variable, this is less than, and less than shades left. So any number that is less than or equal to -2 is an answer to this problem. Okay, number 3. I'm going to circle everything smushed with my x. Whatever's outside my circle, I'm going to add or subtract. So I'm going to move my +4 by subtracting it. My 5/3 x is going to drop down. My symbol is going to drop down. -6 minus 4 makes -10. And then I like to get rid of fractions by multiplying by the reciprocal. There are other ways to do this, but anytime I have a fraction multiplied with a variable, I get rid of it by multiplying by its reciprocal, which is 3/5. And then, of course, I have to multiply the other side by 3/5. I'm going to go ahead and pop my negative 10 over 1, and now I'm just going to work it out. This makes 15 over 15, and 15 over 15 is 1, so all I'm left with is 1x. Or you can think of it as the 3's canceling out and the 5's canceling out. Did I multiply by a negative number? Nope. So the sign does not flip around, so the sign stays the same. And then I'm going to multiply this one straight across. So that makes negative 30 over 5. And what do you get if you reduce negative 30 over 5? Negative 6. Okay, let's go ahead and put this on a number line. So I'm going to put negative 6 on my number line. Would it be an open circle or a solid circle? Open, because there's no equals. Since the pointed end is facing my variable, I read this x is less than negative 6, and less shade left. Less than left. Less than left. Okay, let's move on to the next page. Okay. Here we go. We got quite a bit going on with this equation. On the left-hand side, there's no parentheses, there's no like terms. On the right-hand side, I have parentheses, so the first thing I need to do is distribute my 3. So I'm just going to recopy everything until I get to my 3. And then I distribute. 3 times n makes a positive 3n. 3 times negative 8 makes a negative 24. And then I just bring down the minus 6. Okay, I do have like terms that I can combine on the left-hand side, so let's just do that. What is 12n plus 3n? 15n. And then I can combine the negative 24 and the negative 6, which would make a negative 30. And then I'm just going to go ahead and recopy everything on the left. Okay, on this one, I have n's on opposite sides, so I need to move one of them. So I'm going to move a positive 15n by subtracting it. 15n minus 15n is 0. Shoop. 15n minus 15n is 0. Shoop. I bring down the 45. I bring down the symbol. I bring down the negative 30. I never ended up flipping this symbol because I never divided by a negative or multiplied by a negative. But notice how my variables are gone? They're completely gone. All I have left are numbers. So let's see if this is a true statement or a false statement. Is 45 greater than negative 30? Yes, this is a true statement. Since this is a true statement, this means it's all real numbers, or we could say infinitely many. So if I wanted to represent this with a graph, I would color the whole number line. And that's how I can represent all real numbers or infinitely many, however you like to say it. And there would be our picture. Okay, let's do a little translating. We're going to read these sentences and try to write an equation for them. 16 subtracted from a number is at most 8 decreased by twice that number. So this part right here is at most. That's where our inequality goes, our less than, or greater than, less than or equal, greater than or equal. So let's look at the first part of this sentence. 16 subtracted from a number. Do you see a switch word in there? Yeah, subtracted from is actually a switch word. So I start with the back, a number. I'm going to use x. Subtracted from means minus, and then I'm going to go to the 16. So this is how I write 16 subtracted from a number is at most. What do you think that means, is at most? If I say something like the elevator can hold at most 1,000 pounds, it can hold exactly that amount or less than that amount. So at most means less than or equal. Okay, 8 decreased by twice that number. Is there a switch word in there? No. So 8, write the 8. Decreased by, minus. Twice that number. How can I write twice that number? 2x. Okay, let's solve it. Since I have x's on opposite sides of the inequality sign, I have to move one of the x's. I like to move my smaller one, so I'm going to move my minus 2x by adding it to both sides. And then x plus 2x, remember there's a 1 here, makes 3x. Drop the minus 16, drop the symbol, drop the 8. That's just gone. Now that I'm down to only one x, I'm going to circle everything smushed with it. To get rid of my minus 16, I'm going to add 16 to both sides. The 3x drops, the symbol drops, that adds to be 24. And then I would divide both sides by 3, which makes 8. Will my sign flip? Nope, I never divided by a negative, so no flipping of the sign. Okay, and then I'm going to go ahead and graph it. So I'm going to put 8 on the number line, open circle or closed, closed circle. Since the pointed end faces the x, this is x is less than or equal to 8, less than left, less than left. So this means any number that is 8 or smaller than 8 is an answer to the problem. Okay, number 6. Kevin's history grade will be determined by the average of 4 tests. He earned 76, 85, and 74 on his first 3 tests. He needs to get an average of at least an 80. What is the minimum grade he can make on the 4th test to achieve his goal? So when you find the average of something, you add up the numbers and divide by however many numbers. So he got a 76, then he got an 85, then he got a 74. I want to know what he has to make on the 4th test, so I don't know what that is, so I'm going to call it X. Since there's going to be 4 total tests, I'm going to divide by 4. And then I need him to get at least an 80. What does it mean, at least an 80? Greater than or equal to an 80. You want to get an 80 or something higher than an 80. Okay, this problem would be really easy if I didn't have that divide by 4. So let's make the divide by 4 go away. How can I do that? Multiply by 4. So I'm going to multiply both sides by 4. On the left-hand side, the 4's can cancel out. And on the right-hand side, I can multiply the 80 and 40, which makes 320. I'm going to go ahead and add these like terms here. So if I add 76 to 85 to 74, that makes 235. And then I still have the plus x in there. So now I'm going to subtract 235 from both sides. That goes away, the x drops. And then if I take 320 minus 235, that makes 85. Will my sign flip at all? Nope, I never multiplied or divided by a negative, so sign stays the same. So what this means is his grade has to be exactly an 85 or greater than an 85 on his 4th test in order for him to have an average of at least an 80. So he needs an 85 or higher on his test in order to get the 80% average. And that's all there is. Smiley face!